Thanks for tuning in today, and today we are going to begin talking about something that is an incredibly important thing in chemistry. In fact, a lot of college chemistry professors actually call the first semester of college chemistry this topic, stoichiometry. But before we get into talking about stoichiometry and what that weird word actually is, we are going to review a little bit about chemical equations. So remember, a chemical equation is a recipe for a chemical reaction. It tells you what is in the chemical reaction. So if I have this chemical equation, this is telling me is that 3KOH, H3PO4. The left side of our reaction are the reactants. They're the things that are involved. So when we're calling it a recipe for a chemical reaction, this is like the ingredients. It's telling us what we need in order to do the reaction. On the right side of the equation is the products. They are what's made from the recipe. And if you look at any recipe in any cookbook, you'll see that you've got a list of ingredients. It tells you how much, and then somewhere it's going to tell you what is made and how much of it is made. And that's what this tells you. The last part is the coefficients. The coefficients of a balanced chemical equation tell you how many atoms or molecules of each reactant are needed to make a certain number of molecules or atoms of products. So when you see this, you see that it takes 3 molecules of KOH and 1 molecule of H3PO4 to make 1 molecule of K3PO4 and 3 molecules of H2O. So it tells you how much you need and how much is made, and what you need and what is made. That it is a recipe for your chemical reaction. So when we are talking about recipes, let's think about something that we all like, at least I think we all do, pancakes. All right, so let's say we have a recipe for pancakes, and your recipe for pancakes tells you that you need 1 cup of flour, 1 tablespoon of sugar, 2 teaspoons of baking powder, 1 egg, 1 cup of milk, and 2 tablespoons of vegetable oil. This is what your recipe tells you, and you're supposed to mix it all together and you cook it, and it tells you that it makes 8 4-inch pancakes. Okay, so this is our recipe. It tells me what I need and how much of each thing I need, and it tells me what it makes. But I have a problem. This is the recipe for the pancakes that I have, but I need to make 120 pancakes for a party that we're having. So how do I do that? I'm going to have to figure out how much of each ingredient I'm going to need, so I can have the correct ratio. I can't just throw stuff in there, because then it will come out and they'll be nasty pancakes, either too hard, too soft, too soupy. They'll just be nasty. So in order to get the pancakes to turn out the way they're supposed to and get the number of pancakes that I need to know how much of each ingredient I'm going to need to start with. So what I need to figure out is the ratio between the two amounts, and then I multiply. So I know I need 120 pancakes. Well, my recipe makes 8. Well, the ratio of 120 to 8 is a multiplier of 15. So that means I would have to then multiply all of my ingredients amounts by 15. So that is basically what we're doing with stoichiometry. Stoichiometry is the skill of using how much I know I have to figure out how much I'm going to get. It's a way of determining the amount of products produced from a given amount of reactant. If I have this much of one reactant, how much of my product can I make? Or if I have this much of this reactant, how much of this reactant do I need to react completely together? It's a way of looking at what I have and what I need and figuring out how much of each of those work together. So how much reactant is needed to produce a certain amount of product. That's what stoichiometry is telling us. And the key to stoichiometry is something called the mole ratio. And oftentimes you'll actually hear it referred to as the stoichiometric ratio. And I will actually refer to it as a stoichiometric ratio from time to time. But your mole ratio, it's a ratio of moles. So how does that work? The ratio of moles, the mole ratio, is a comparison of the number of moles of one substance with another substance in the reaction. So, The coefficients of our balanced chemical equation are what tell us how much of each thing we have. They tell us how many atoms or how many molecules of this reactant are needed to make a certain number of molecules of this reactant, or a certain number of atoms of this product. So that's what the coefficients tell us. They tell us the number of atoms and the number of molecules involved in the reaction. But as we just learned when we're talking about moles, the number of particles in 1 mole is the same for all substances. So logically, that would tell us that if I have 1 mole of this compound and 1 mole of this compound, I have equal numbers. So if the coefficients tell us the numbers of atoms, and I multiply them all by Avogadro's number, then I would have 1 mole of all of those. So logically, the coefficients of the balanced chemical equation also tell us the number of moles of each substance we have, which is great because it's really hard to measure 1 single atom of something, but it's really easy to measure 1 mole of something. We simply measure its molar mass. Now the mole ratio compares these amounts of substances by making ratios or fractions out of coefficients of the chemical equation. And as we learned when we did unit conversion, the ratio, those fractions, can be flipped so that the units cancel in a certain way. And that is the goal and the key to stoichiometry. And that is the power of the mole ratio. So when you're looking at a chemical equation like this one, same equation we had earlier, now this time I added 1s for the coefficients of phosphoric acid and potassium phosphate. I just added those 1s so that you could see them. Again, we don't normally write the 1s for our coefficients, but you'll see we have 3, 1, 1, 3 are the equation or the coefficients of our balanced chemical equation. So, some possible mole ratios. This is not all of the mole ratios, but here's some possible mole ratios. I have 3 moles of KOH. I could have 3 moles of KOH on the bottom and 3 moles of H2O on top. That is a mole ratio. It's a 3 moles of water to 3 moles of potassium hydroxide. I could also have 1 mole of potassium phosphate over 3 moles of potassium hydroxide. It's using these coefficients. So we have 1 mole of phosphoric acid and 1 mole of potassium phosphate. Again, the mole ratios are ratios of the moles. So here are some others. So these are 3 or 6 of the possible mole ratios from this particular compound. There are more that we could do, but these mole ratios end up becoming basically like conversion factors for us when we are doing our stoichiometry. Stoichiometry at its core is essentially a unit conversion. We're just not converting units, we're converting substances as well. This is why I made a big point to make sure you always know to write down the chemical substance along with your units when you're doing unit conversions so that you don't get confused when you do stuff like stoichiometry. So let's look at how stoichiometry works. First, you have to have a balanced chemical equation. If you're given an equation, you need to always double check to make sure it is a balanced equation first. If it's not balanced, then it is your responsibility to balance the equation before you start doing stoichiometry, because the mole ratio, the key to stoichiometry, comes from the coefficients of our balanced chemical equation. Well, if you don't balance the chemical equation, then you can't do stoichiometry. That's the very, very first step. The next thing you're going to do is convert whatever unit you're given in the problem, you have to convert it to moles. Because in order to use the mole ratio, my unit has to be in moles. So if I'm given grams, I convert it to moles. If I'm given liters, I convert it to moles. If I'm given particles like atoms or molecules, I convert it to moles. If I'm given moles, then I'm down 1 step. I don't have to convert to moles, I just move on. After you've converted to moles, we're going to set up our mole ratio so that your substances will cancel out. Whatever substance you have on the top has to be in the bottom of the next one so that they'll cancel out. And whatever substance is on the top is what you're looking for, the substance you want to know about. So you're going to set up your mole ratio so that your substances will cancel properly. And the last thing you're going to do is convert from moles to whatever desired unit. Because after you do your mole ratio, you remember step 2, you convert it to moles, we do our mole ratio, so our unit is still moles. But if the problem wants grams, then we have to convert from moles to grams. Or if the question wants molecules, we have to convert from moles to molecules. So it's basically a step of 3 conversions. We're going to convert from whatever unit we have to moles, then we're going to convert from moles of one substance to moles of another substance, and then we're going to convert from moles of that substance to whatever it is that we're asked to solve for. So here is our equation. We're just going to keep using the same equation for our example problem. And suppose that I have 319.4 grams of potassium hydroxide and an excess of phosphoric acid. Now when you see the word excess, that just means I have more than enough phosphoric acid to completely react all of the potassium hydroxide. So I have an excess of phosphoric acid. How many grams of potassium phosphate are going to be produced? So that means I have 319.4 grams of potassium hydroxide, and I want to know how many grams of potassium phosphate are going to be made. So I want to know how many grams of potassium phosphate are going to be made. So this is what I have, that's what I need to get to. So just like any other conversion, I'm going to start with what they give me in the problem, 319.4 grams of potassium hydroxide. And then I set up my grid. And I'm going to convert, the first step I'm going to convert to moles. So if I have grams of KOH here, I need to have grams of KOH down here. And I'm going to put the molar mass of potassium hydroxide. So hopefully by now you know how to find the molar mass of a compound. And that's going to convert it to moles of KOH on the top. So you'll see that my grams of KOH are canceling. I'm left with moles of KOH. So now the next step is to set up our mole ratio. If I have moles of KOH on the top, I need to have moles of KOH on the bottom. And I'm trying to find KPO4. So I'm going to put moles of K3PO4 on the top. So you'll notice that my substance has changed. The units are still moles, but the substance has changed. Now, before I told you with the conversions, it's always 1 mole. Well, if you're converting from moles or to moles or using that mole roadmap, it's always 1 mole. But when you do the mole ratio, if I have moles over moles, the numbers here come from my balanced chemical equation. So when you look at the balanced chemical equation, the coefficient of KOH is a 3. So I have 3 moles of KOH, and the coefficient of K3PO4 is 1. So I have 3 moles of KOH are required to get 1 mole of K3PO4. So you'll see that my moles of KOH now cancel out, and I have moles of K3PO4. But the question wants grams of K3PO4. So I need to keep going. And I have 1 mole, this time it's 1 mole because I'm converting. So 1 mole of K3PO4 is going to equal the molar mass of K3PO4, which is 212.264 grams of K3PO4. I'm running out of room there. So now my moles of K3PO4 cancel. I'm left with grams of K3PO4, which is what I wanted. So now I'm going to do my multiplication. And you'll notice I have 2 numbers on top and 2 numbers on bottom. So I'm going to multiply the numbers on top. So 319.4 times 212.26. And then I'm going to divide by the numbers on the bottom. Divided by 56.105 and divided by 3. And when I put all that in my calculator, I get an answer of 402.3450468. But just like we've been doing, we have to round to the proper number of significant figures. Well, my number I started with is 1, 2, 3, 4 significant figures long, so I need 1, 2, 3, 4 significant figures. So my final answer is 402.35 grams of K3PO4. All right. Now, some of you may be noticing, I just now noticed that I wrote down the wrong number here based off of what is typed on the screen. So the problem works out the same way. Regardless, you're just going to have slightly different numbers with a 0.04 instead of a 0.4. I'm not going to go back and refilm that, so sorry for my mistake. So after seeing that example, we know that stoichiometry is a way of taking from one substance and converting to another substance. You have one amount of one substance and finding another amount of another substance. I did one example for you here on this one. In the next lesson, I'm going to do a lot of examples of stoichiometry so that you can see all the different ways that we could do that. So stay tuned for that. Hopefully you can watch this again, get the process, make sure you know how to do mole conversions and just basic unit conversions. If you know how to do that, this is super easy. So thanks for watching and have a day.